Hello everyone, welcome to VLearn Tutorials. In this video, we are going to do Newton's laws of motion. So, 3 laws we will discuss in this video. So, let's start with the first law. So, the first law of Newton, it states that every object, it will remain at rest or in uniform motion in a straight line unless compelled to change its state by the action of any external force. So what does it mean? It means if any object, it is in a state of rest, so it will be in the state of rest until you apply some external force. Or if any object, it is in motion, it will be in its state of motion until you apply any force to stop its motion. So this is also known as law of inertia. So why law of inertia? Because inertia, it is the tendency of any object to remain at rest or in a uniform motion. So due to which it is also known as law of inertia. Inertia is of 3 types: inertia of motion, inertia of rest and inertia of direction. So let's understand the meaning of all the 3 types of inertia. So here we will discuss examples of first law of motion and understand the meaning of inertia. So you can see first figure here, and this ball is in state of a rest. So it will be in state of rest until you kick this ball to change its state. Now you can see here you are kicking this ball, due to which it starts moving. So when this object it continues to be in its state of rest, it is known as inertia of rest. Now this ball is moving, so it will keep on moving until it is stopped by any force. You can see that. So this tendency to be in its state of motion, it is known as inertia of motion. So basically you have to understand, if a body is continuing its state of rest, it is inertia of rest, and if a body it continues its state of motion, it is inertia of motion. Now let's understand inertia of direction. So here I have given one example of inertia of rest. This we can say it is application of inertia. So this is when you clean a carpet, you beat it with a stick. So this carpet, it will come into motion, but the dust particles in this, it will be in its state of rest, due to which the dust particles, they will be removed by beating the carpet. So this is an application of inertia of rest. We will discuss few more applications once we discuss all the laws. Now let's understand the meaning of inertia of direction. This is very common example. You might have experienced also. So whenever you are driving a car or you are just sitting next to driver, if a driver immediately applies a brake, you can feel a jerk. So why you feel a jerk? You feel a jerk due to inertia of direction, we can say. See, your body, it was in state of motion, but once the brakes are applied, the car, it will come to the state of rest, but your body, it continues to move in the same direction. That's why it tends to move forward and you feel a jerk. So this, we can say it's both example of inertia of motion also and inertia of direction also, because your body was in motion and it tends to move even the brakes are applied. That's why it's move in the forward direction. Now let's discuss the second law of motion. So Newton's second law of motion, it states that the rate of change of momentum, it is directly proportional to the unbalanced applied force. So what is momentum? Momentum, it is the product of mass and velocity. So its formula is this, we can say, and it is represented by symbol P. P is equals to mv, where m is mass and v velocity. So the rate of change of momentum, it is directly proportional to unbalanced applied force. So this is stating the second law of Newton, which means force, it is directly proportional to change in momentum. So what is that? We'll understand now. So if we have any object of mass m and it is already moving with any velocity, initial velocity u, and you applied force. See, it was already moving with velocity u, you applied force to move it till, and it reaches till here, its mass is m, and it will acquire final velocity v. Then the rate of momentum, the rate of change of momentum, it is directly proportional to the force. So what we will get from there? So rate of change of momentum means, first of all, what is change of momentum? Change of momentum will be final momentum minus initial momentum. P I can write because its symbol is P and it is telling us rate of change. So rate of change means it is divided by time. So I was discussing the change in momentum. For example, its initial momentum, it is, for example, 20 kg meter per second. So finally it will be 30 kg meter per second. So what will be the change in momentum? It's understood, it will be from here to here. If the object is moving, its change in momentum will be 30 minus 20, which is 10. So change in momentum, it is final momentum minus initial momentum. So according to second law, the rate of change of momentum is directly proportional to applied unbalanced force. Now we will write the values, which means F is directly proportional to final momentum means m into v, because final velocity is v, minus initial momentum, it will be m into u upon time t. So now I will just take, because I can see m is present in both the terms, so I will take m as common. So I am left with, if m I am taking out, remaining things I have to write inside, which is v minus u upon t. So I got F is equals to, now we have already learnt in chapter motion that v minus u upon t, it is equals to acceleration. So from here we got force is directly proportional to, this is, I am just substituting the value of A, this is A. So force is directly proportional to mass into acceleration. So now this is a sign of proportionality. This sign we have to remove by equal to. So whenever we have to remove the sign of proportionality, we have to write any constant k. So from there I got F is equals to k into ma. So experimentally it's already proven that the value of this k is equals to 1. Because whenever it is tested, if a mass of 1 kg, we are applying a force of 1 Newton, it is producing an acceleration of 1 meter per second square. So that means if everything is 1, this is also 1. So it is proven experimentally that k is equals to 1. So which gives us the formula F is equals to mass into acceleration. So this formula of acceleration, force we have got from second law of motion. This formula also you can use, that force is equals to mass into v minus u upon t, and this also we can use. Now let's discuss the few application of Newton's second law of motion. So now we have already understood Newton's second law of motion, and it is giving us the formula of force. Force is equals to mass into acceleration. Also it is giving us this formula if we express the formula of force in terms of momentum. So from here you can see Force, it is directly proportional to mass and velocity, and it is inversely proportional to time. And if you see this formula, force is directly proportional to mass and acceleration. So this definition or these formulas we can use in our practical life also. Let's discuss few of its applications. You can see here, this player, he wants to catch a ball. So just now we have done this formula. According to this formula, force and time, they are inversely proportional to each other. Inversely proportional means if time it is more, force will be less, and if force is more, time will be less. So inverse relation is there. If one thing is increasing, the other thing will decrease. Now you can see here, if a person, he catches the ball directly, see, time will be very less. Time, if it is less, he can be hit badly by this ball because force will be more. Now if he shift his hands or if he move his hands in this position, you can see now he can increase the time of catching a ball. If the time will be increased, force will be less. So he won't hit that badly as in this case. So this application we can use in a real life also. If we increase time of anything, its force will be decreased. Now let's see. And here we have discussed force is directly proportional to mass. So which means if you are pushing a mass, something which has more mass, you have to apply more force. On the other hand, if any object it has less mass, you have to apply less force, because force and mass, they are directly proportional to each other, which means if force it is more, if mass is more, force will also be more. If mass is less, force will also be less. Now let's move towards the Newton's third law of motion. The third law of motion states that for every action there is an equal and opposite reaction. So let's see this figure. How is that so? You can see this boy, he is moving in the forward direction, but you can see if he moves in the forward direction, this boat, it will move in the backward direction. So one of his leg is giving action and the other leg it is giving reaction. So same can be applied during walking also. So it describes that every object, it is giving an equal and opposite reaction. So let's discuss few more examples. So I have taken the examples, those examples also which are given in your book. So this one is given rocket propulsion. You can see the rocket, it will move in the upward direction and the gases, they will move in the downward direction. So one thing, this is on this body, action is there and the gases, they are giving the reaction, due to which rocket is able to move in the upward direction. So same way you can see action and reaction are involved here. Now recoil of the gun. When the gun is fired, you can see bullet will move in the forward direction, but on your shoulder you will feel a jerk in the backward direction. So this direction of bullet and direction of recoil of they both are in opposite direction. One thing is action and the other thing is reaction. So this is also an example of Newton's third law of motion. So the common example you can see, compressing a spring. This you can try also. So once you compress a spring, after you remove this force, it will bounce back. So compressing, you can say that is action force, and bouncing back of the spring, it can be reaction force. So all these examples were based on Newton's third law of motion. Now let's discuss few related questions. So these questions I have selected from textbook. You can see question number first. Which of the following has more inertia? A rubber ball and a stone of same size, a bicycle and a train, a 5 rupees coin and a 1 rupee coin. So you have to understand one thing, inertia, it is the product of mass. So whichever thing has more mass, its inertia will also be more. So let's try to answer according to this concept. We just have to see whose mass is more. If mass is more, inertia will be more. So a rubber ball and a stone. So it's quite understood that stone, it has more mass, due to which it will have more inertia. Same way, bicycle and train. Train, it has more mass, due to which it will have more inertia. A 5 rupee coin and a 1 rupee coin. Again, 5 rupee coin, it has more mass, due to which it will have more inertia. You can see, as mass of the object is a measure of its inertia, so the object with more mass will have more inertia. Now let's discuss the second question. So explain why some of the leaves may get detached from a tree if we vigorously shake its branch. So here again it is due to inertia, and we have to understand which inertia is this, because we have already learnt inertia is of three types: inertia of rest, inertia of motion, and inertia of direction. So you can see here, if you shake the branch of a tree, see this branch, it will come into motion, but the leaves still they are in state of rest. Since the leaves are in state of rest, due to which they will get detached due to inertia of rest, because leaves, they will tend to remain in the state of rest, whereas this branch, it will come into motion once you start shaking it. So you can write here, the leaves may get detached because due to inertia of rest they tend to maintain their state, while due to which some of the leaves they can get detached. So basically you have to understand it is due to inertia of rest. You can imagine the situation, just try to shake the branch and you can imagine what will happen. The next question, when a carpet is beaten with a stick, dust comes out of it. Explain. So this I have already explained at the starting. So it is again due to inertia of rest. See, you are beating the carpet, due to which the carpet, it will come into the state of motion, but the dust particles, they still try to maintain their state of rest, due to which they will be removed from the carpet. So simple, it is due to inertia of rest. So anything, you have to remember one thing, anything which is trying to maintain their state of rest, that means it is inertia of rest. And if the other thing, if anything is trying to maintain the state of motion, then it will be inertia of motion. Now let's do the next question. Why do you fall in the forward direction when a moving bus applies brakes to stop? This again I have discussed at the starting. So when a bus is moving, your body is in state of motion, but once the bus applies brakes, so what will happen? Your body, it tends to be in its state of motion due to inertia of motion, or we can say it tends to move in the forward direction due to inertia of direction also, but your downward body part, it will come to rest because it is in contact with bus and the bus is already in state of rest due to the application of brakes. So this is due to inertia of motion, due to which you fall in the forward direction, and we can say you can feel a jerk also. So this was due to inertia of motion. Now let's discuss the next question, and you can see that in all the questions you just have to figure it out whether something is happening due to inertia of rest or due to inertia of motion. You just have to imagine the situation. Now why do you fall backwards when a car accelerates from rest? So it is completely opposite to the previous question which we have discussed. So in the previous question the bus was in motion, but in this question the bus or car, we can say, it is in the state of rest. So what will happen? Your body is also in the state of rest, but once you accelerate it, the car, it will come into the state of motion, but your body still it is trying to maintain its state of rest, due to which it will fall backwards due to inertia of rest. So these were all the important questions of Newton's first law, and all the laws I have already discussed. If you have any doubts related to any law, you can post your comments in the comment section. If you like the video, do like, do share. Thank you so much for watching the video.